All right, welcome to our first video on our of discrete mathematics. In our first unit, our class is broken down into multiple units and then multiple subsections in each unit. The first unit we look at is set theory and its applications. So in order to understand what set theory is, you have to look at its three main parts, and its three main uses are set notation, Venn diagrams, and logic. Today we're going to look at set notation. So what is a set? A set is a collection of distinct objects called elements or members. So remember when we talk about what is discrete math, it's the study of the whole number. And when we talk about whole number objects, that means things that have to be distinct. Okay, so how do we describe a set of elements? This is typically what we look for. For a set, it's going to have a title, and then it's going to have elements or members. So a title is typically always a capital letter. Then you put these set bars, set brackets. You put all of the members and you close the set bracket. So this means the set M, that's the name of the set, consists of elements A, B, C, and D. These are the members of the set called elements. And then we have another set N that just has D, E, and F in it. And you can see that's typically, there's fixed outcomes, okay? So distinct, important to understand the word distinct. Distinct, we mean an element cannot be repeated and must be well defined. I'd say the most common mistake with making sets is thinking that something can be repeated, like could have two letter B's or two letter C's. Nope. Once the letter C is in the set, there's no repeat. All C's, if you see a C is in the set. There's no reason to write it twice. So A, B, B, C is not a set, since B would not be distinct then. And in addition, you have to say that it has to be well defined. So if I say just Q is the three largest integers, that's not really a set, because there is no such thing as the biggest number ever. There's no biggest number in existence. So you can always think of a number bigger than the previous one. So I can't say that Q is the three biggest numbers. Integers are numbers. The three biggest numbers, because there's always a number bigger. So it's not defined. Well defined means you understand what's in it and no repeats. So what we're going to look at is kind of how to write sets today, the notation behind sets. So a set can be finite, which means it has a countable number of items in it, or a set can be infinite. Infinite sets we will deal with less, but infinite sets are something like if I said to you all even numbers. Well, if even numbers would be 2, 4, 6, 8, it would go on forever. It would never stop, but it is well defined and distinct, meaning I know what it is and there's no duplicates. So it can go on forever. Sets can also have no elements. So our first symbol or notation for today would be the empty set. And the empty set is called the null set or empty set. You can write it two ways. You've probably written this circle with a line through it in your classes before. That means nothing, empty, null. Or you just put a bracket, empty, a bracket, meaning there's nothing inside of the set, empty set. Next notation, we're going to work with our sets M and N that we talked about before. How do we indicate that an element is in a set? Meaning, how can I tell someone in math phraseology using notation, oh yeah, like B is definitely in M. You wouldn't write it as is in or is an element of. We're going to learn this symbol right here, this little kind of squiggly E. A is in M. That's all it means. It's just shorthand for saying is a member or is an element of the set. It's much easier to write this little E than to always write is an element of set. So it's shorthand. That's what we're learning today. So most of the time, like math, always if we have equal to, not equal to, you just cross a line through anything. So A is in M versus here A is not in N. Why is A and not in N? Look at N. It's just D, E, F. So A is not in N. Not an element or not a member of the set. So sets in mathematics are often described in words, but we will not be using these exact crazy All these symbols, we'll be using some of them, meaning we just learned this is in. We learned set notation, but this vertical line means given that or such that. This capital R means the real numbers, and then X is greater than 2. We won't be using this entire kind of sentence. This is called like a set notation sentence. We're not going to be writing all these sentences. You're just going to be working on the symbols we talk about. How do we indicate that all of the elements of one set are combined in another? So subset, what does that mean? So meaning everything is in one set is already in a bigger set, subset. So to show that a set is a subset of another, you just get this kind of elongated C. So suppose P, a new set P, is just A and B. Well, we know that the set we've been using, M, has A, B, C, and D. So P, everything that's in P is in M, no exceptions. A subset has to be completely in here. So it can't be like A, B, W. Because W is not an M, P would not be a subset of M. If you have a smaller set and everything in that smaller set is in a set bigger than it, then the smaller set, P, is a subset of M. P is a subset of M. Okay. M and N, same thing. So, union means to unite two sets. It means to bring them together and make a monster set. It means to put all of it together. So unite sets can be this U symbol for union, or sometimes you will see it as a V. This V is typically if you look at a European paper. This U is typically if you look at an American paper. But you see both of them. So M union N means to bring them all together. It also means or. When we get into later questions, it's going to say, what's an M or N? That's sometimes a mental block for my students where they say, no, it's an or. It can't be in both. But it absolutely can be in both. So D is in both sets. D is in the union. M or N does not mean just one or other. Those totally separate things in math. Or just means union, or means unite, or means put it all together. So I have an A, B, B, C, C, D. And now, please note, D is repeated, but you would never ever repeat it. You know that never happens in sets. So the union of the two is just to have an A, B, C, a D, an E, and an F. That means union, it means or, it means unite. But remember that or does not mean one or other. That's not what or means in math. Or means to bring all together. Or, meaning all of them. Is a D in M or N? Yes, D is in M or N. It is both, which means it's in or. Okay, the opposite of a union is to look at intersection. It means overlap. It is the word and. It makes exact sense like everything you've ever learned, meaning it has to be an M, and our set P. So we're looking at M again, A, B, C, D. P is A and B. Intersection symbol is just an upside down U or an upside down V. So it's just flip over the union symbol. It means what is in both. It has to be in both. Only things in both. A is in both. B is in both. C and D are not. So the answer is just A and B, and you just write it once. That's the intersection, also called the overlap, also called and. Tilde in math, that little tilde, means not. So what does not R mean? This means not in R. Okay? This is also where we learn something called the universal set. There are a lot of problems where a universal set will say, you can only look at these certain numbers. So maybe a universal set will just be only look at 1 through 10, only look at 1 through 20, only look at A through Z. Only look at the consonants, only look at the vowels. So to have a universal set makes you understand, what is the big picture here? What are the things I'm looking at in whole? That'd be the universe. So If the universe is R means real numbers. If the universe was the alphabet, that would be A through Z. So let's look at complement or not with our universe. So suppose the universal set is all letters in the alphabet. Okay, so that's good. They tell you the problem. Like, so you know you're just looking at the American English alphabet. The set R is the set of consonants, including Y. Okay, so they say R is going to be all the consonants, including Y. Not R would be anything outside of the consonants and Y, which would be A, E, I, O, U. Not something is called the complement of the set. You need to have this universal set so you know what everything is. That way, if someone said what's not R, you know it's the rest. The rest. In math, the way of saying what's the rest of everything, what's not included, what's opposite, is called the complement. Complement, just like we had different symbols that mean the same thing, complement can just mean this tilde R. It could be R raised to the C, that's complement of R, or R with a line on top. All three of those in different languages and different forms of writing math do indeed mean just complement or not what is in the set, so everything outside the set. Okay, subtracting of sets. Subtracting of sets, to some people kind of like, oh, this kind of looks like intersection, but it's not. It legitimately is subtraction of sets. It's saying start with M and subtract out the things that are in Q. Okay, it's the difference. It's subtraction. The difference between M and N or M and Q or M and anything is to start with the first one and take away only things that are in the second one. The hardest part here is that people add things out of nowhere. Take a look very carefully. M is only A, B, C, and D. M is the starting point of the subtraction. Never ever will I get anything more than what is in M. So if I look at Q, if I said A, B, C, D, take away B and E, do I still have an A? Yes. B got subtracted. Do I still have a C? Yes. Do I still have a D? Yes. And then people say, well, what about this E? I didn't do anything with it. That is completely okay. Since E was never in the starting set, it just doesn't matter. Right? B gets subtracted. Nothing happens with E. It is totally okay. Note that we don't include a negative E. We don't include anything. The E just doesn't matter. Since it wasn't in the starting set, it is just a moot point. It does not matter. Starting set, subtract things in the subtraction set. Whatever is left is the answer. We're almost at the end. We have gotten through these symbols today. These are the symbols we are going to work with today. So we started with how do I make a set? You put brackets. How do I say something is a member or element of a set? Meaning little thing in big set. E, rounded E. Not a set. Empty set. Subset. Not a subset. Union, unite, meaning or, meaning anything and everything. Intersection, just the overlap, and complement, not in a set. We're going to finish with a practice session. Notice how they say the universal set here is just the numbers 0 to 9. So that's good for us. It means we don't have to think about anything other than 0 through 9. And we're just going to use these sets, M, N, P, and Q, and the fact that the universe is just 0 to 9, meaning the universe is just 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So those are the only things we possibly could use. We typically say this is capital U for universal set. And let's get into it. M, unite, meaning or, meaning all. Union means all. M, all with N. No repeats. So start from lowest, go to highest. Do I have a 0? Yes. Here's my 0. It's used. Do I have a 1? Absolutely. 1. Do I have a 2? Yup. And then I have a 3. Then I have a 4. Then I have a 5. I already used the 2, don't repeat it. I already used the 4, don't repeat it. This one's all done. All that's left is 6 and 8. Union is to unite. It is everything. It is no repeats. Keep all of that in mind. Okay, I won't cross these out again so we can keep seeing them. But that was union. Intersect. Start with a bracket symbol. It has to be in the overlap. Is 1 in the overlap? No. Is 2? Yes. Is 3? No. Is 4? Yes. Is anything else in the overlap? Not at all. That is it. Those are the overlap. That means and. Okay, moving right along. M intersect, so 1, 2, 3, 5, intersect with 1, 3, 7, 9. Well, the only things that intersect there are 1 and 3. Overlap. And. Okay, next one is not N. Well, when you think of not, you should always think about then what is the universe, because you have to think what is everything in the universe not in N. Everything in the universe not in N. So 0 is in N. 2, 4, 6, 8 are in N. So the things that are not in N would start with 1, then 3, then 5. 1, 3, 5, 7, and 9. Those are the things not in N, but still in the universe. Okay. The next ones start to get a little harder. The next two. Two of them are a little harder. N intersect not P. So when you get these multiple step ones, it makes it very easy if you think about them one piece at a time. Like saying what is not P first. If I said what is not P, I can just write it right here. Not P would be the set, well, anything other than 1, 3, 7, 9, which would be 0, 2, 4, 5, 6, 8, and that's it. Because then I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. Now I'm going to intersect not P, so this black answer right here, just these numbers. What is overlapping with N? 0 is in the overlap, 2 is in the overlap, 4 is in the overlap, 6 is in the overlap, 8 is in the overlap. It is completely okay that our answer is actually just the set N. It's okay. Again, how did we do that? I made it smaller steps. Not P. I made not P. And then I said, what overlaps with N? What overlaps right here? Easy. Okay. P union Q. And then we're going to subtract Q. Okay. Take it step by step. Union means to unite. P and Q united would be, we're going to do this part first, parentheses first, just like math. P union Q, I will do it right here in this green color. So if I unite them, it's everything. I have a 1, I have a 2, I have a 3, I have a 7, I have a 9. The green is this green. This is P union Q. Now I'm going to subtract Q. So I'm going to take away anything that's in Q. Take away 1, 2, and 3. What am I left with? I am left with just 7 and 9. Okay. These is questions are yes, no questions. That's all it is. Yes or no. Is Q a subset of M? To be a subset, everything in Q has to be inside of M. So I just go one at a time. Is a 1, a 2, and a 3 all have to be in M? Yes, 1 is in, 2 is in, 3 is in. The answer is yes, because everything that's in Q is in M, so Q is a subset of M. Just a yes, no question. The last one just says, is 3 a member of P? So just look at P. Is 3 inside of P? Absolutely. This is also a yes. So you're going to work on some questions now. We are going to practice how you guys do at this with your own set of questions. Use these as an example. But that is it for our first video.